Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how we find time when we're working with compound interest. Here's the formula that we've been using for compound interest. A, which is future value, will equal P, which is principal or present value, times 1 plus R over N, where R is the annual interest rate, N is the number of compound periods per year, and that expression is raised to the exponent of N times T, where T is the time in years. In previous videos, we've talked about how we can solve for A when we know the other values, or P, or R. In this video, we're going to talk about how we solve for time. This formula might look a little bit more complicated than other compound interest formulas, but it's basically the same. This value here represents the interest per compound period, and this represents the number of compound periods. In order to explain how we're going to solve for time, let's jump right into an example. In our first example, it says, how long did it take $5,000 to grow to $8,458.66 if it earns 7.8% compounded annually? Let's start out writing down what we know and putting those values into our formula. So future value is $8,458. That goes in for A. Principal or present value is $5,000. Interest rate as a decimal is 0.078, so that goes in there. And if it's compounded annually, that means once a year, so the number of compound periods per year is 1. So we put that in for N here and for here. Let's simplify this. When I simplify 1 plus 0.078 over 1 to the power of 1t, I get this. And I want to isolate this factor, so let's divide both sides by 5,000. When I divide this by 5,000, I get exactly 1.691732. My unknown is in my exponent. That's called an exponential equation. And the technique for solving exponential equations is taking the logarithm of both sides. Your calculator has two bases for logarithms, base 10 and base e, which is called the natural base. In business, it makes sense to use base e, or the natural base. So we're going to take the natural log of both sides of the equation. The notation for natural log is ln. So I've taken the natural log of both sides of the equation, and the reason I did that is because there's a property of logs that allows me to take my exponent out of exponent position. When I have the natural log of a quantity to an exponent, that's equal to that exponent times the natural log of that quantity. Let me show you. So in other words, the natural log of 1.078 to the power of t is equal to t times the natural log of 1.078. Now that the t is a factor, I can isolate it. I'm going to divide both sides by the natural log of 1.078. So I'll have t equals the natural log of 1.691732 divided by the natural log of 1.078. If you're using the Texas Instrument Business Analyst calculator, then you will find your natural log function right here. So the way that you're going to enter that is you're going to put the number in first and then press natural log. So 1.691732, press natural log, divide by 1.078, natural log, equals. And when you do that, you'll get a value of 7. Time is in years, so 7 years. Our next question says a $10,000 investment has an interest rate of 6.25% compounded monthly. When will it be worth $16,465.83? So let's write our formula and then write down the values that we know. So we know the future value is $16,465.83. The present value is $10,000. Our interest rate as a decimal is 0.0625. And because it's compounded monthly, that means that there are 12 compound periods in a year. Let's plug these values in, and our equation looks like this. First step, let's divide both sides by 10,000, and we get 1.646583 equals 1 plus 0.0625 over 12, all raised to the power of 12t. Now I want to keep this value exact, so what I recommend that you do is find this value and store it in the memory on your calculator. If you use a rounded off value that you write down, you're going to have rounding error in your answer. So let's find this value, and I'm going to write it down rounded off, but I'm going to store it in my calculator. And the way that you do that on this calculator is you enter store and then go location 1. You can choose whatever location you want. I'm going to store it in location 1. And then when I want to bring it up, I go recall 1. So when I do that calculation, I get 1.0052. But like I said, I've actually stored the actual value on my calculator. Now to solve this, I'm going to take the natural log of both sides, and I'm going to use my property of logs that allows me to bring the 12t in front. My next step is to isolate 12t, and I do that by dividing both sides by natural log of 1.0052. So I will get 12t equals natural log of 1.646583 divided by natural log of 1.0052. So on my calculator, I'm going to go this value, press natural log, divide by, recall this from the memory, so recall 1, natural log, equals. I get 95.999996 and so on. I'm going to round that off to 96. And now I'm going to divide both sides by 12. And I get t equals 8 years. So it will take 8 years for this investment to grow to this amount at that interest rate compounded monthly. In this example, it says your client invests $4,000 today at a rate of return of 5.35% compounded quarterly. How long will it take the investment to grow to $5,650.47? So let's start by listing the values that we know and then plugging those values into our compound interest formula. We know future value, we know present value, and we know our interest rate. It's compounded quarterly, which is 4 times a year, and we're finding time. We plug those values into our compound interest formula and we get this. So first of all, I'm going to divide both sides by 4,000. And I'm going to simplify this into one number, but I'm actually going to store it in my memory and use the actual number instead of my rounded off number. Now I take the natural log of both sides. Then I use my properties of logs to bring this out front. Now I divide both sides by this value. And I will get the natural log of this value divided by the natural log of this value equal to 4t. Let's calculate this. The value should be 26. And now let's divide both sides by 4, and t will be 6.5 years. Let's talk about the formula and do the same question using the formula, and then you can decide whichever method you prefer. Here's the formula that we're going to use. And in case you're interested in how I obtain that formula, if we go back to our compound interest formula and we solve for t, so first step, we're going to divide both sides by 8. Then we're going to take the natural log of both sides. Then we're going to use our properties of logs that allows us to take that nt and write it as a coefficient. And then to isolate t, I'm going to divide both sides by n and natural log of 1 plus r over n. So if that interests you, fine. If not, here's the formula. Let's now take this question and plug into our formula. So t will equal the natural log of a over p divided by 4 times the natural log of 1 plus 0.0535 divided by 4. In order to avoid rounding errors, I would suggest that you first of all find this value and store it in a memory on your calculator, and then recall that value when you're typing everything in. A question you'll often see when you're working with finding time with compound interest is something like this. How long does it take for an investment to double if it is earning 8.96% compounded semi-annually? We don't know the amount and we don't need to know the amount. We can pick any value and then we double it. So in order to make this easy, let's say the present value is $1, therefore the future value will be $2. You could choose 1,000 and this would be 2,000 or whatever. As long as this value is double, that's all that matters. Our interest rate is 0.0896. It's compounded semi-annually, so that means there are 2 compound periods in a year, and we're finding time. Let's solve this one by using this formula again. So we take natural log of a over p. A over p is 2 over 1, so that's just 2. So natural log of 2 divided by n, which is 2, times the natural log of 1 plus r, which is 0.0896, divided by n, which is 2. So I'll get natural log of 2 divided by 2 times the natural log of 1.0448, and you should get a value of 7.91 years. Now let's take a look how we can find time using the function on your business analyst calculator. So let's do this example with our calculator. It says a $10,000 investment has an interest rate of 6.25% compounded monthly. When will it be worth $16,465.83? We're going to be using these white buttons on your calculator for any compound interest calculations, and they allow us to find any value as long as we know the other ones. We know the interest per year is 6.25, and we can write it as 6.25 rather than a decimal. Present value is 10,000. We make present values negative. And this represents future value, which is $16,465.83. To start, we're going to press the Clear TVM button, which is above the Future Value button. So go Second Function, Clear. That clears any other work that might be in there from previous questions. We're also going to enter our payment per year and compound periods per year. If it's compounded monthly, then the compound periods per year is 12. So we're going to go into P per Y, which is above the I per Y. So second function, P per Y. We want it to be 12, so we enter 12, and remember we have to press the Enter key. And then if you scroll, you'll see the compound periods per year is 12, which is what we want. And now we're going to exit this, so second, quit. Now we can enter all of these values, and you simply put the number in and then press the function. So in this case, that's our interest per year, so we enter that. Present value is negative 10,000, so 10,000. Change sign to make it negative, enter that as present value. Then future value is $16,465.83. We enter that as future value. We want to compute N, so compute N, and we get 95.999. That rounds off to 96. That represents the number of compound periods. Because it's compounded monthly, that would represent 96 months. And if we want to know how many years, we simply take that and divide by 12. So 8 years. If you want to do another question, make sure that you clear your display and clear the worksheets. And now you can do your next question.